20 in your book, there are some definitions regarding polynomials. So if you look at polynomials, right here, polynomials in standard, oh wait, let's go above that, sorry. So right up here, an expression formed by adding a finite number of unlike terms is called a polynomial. The variables can only be raised to a positive integer exponent. So you see a couple examples. 4x to the third minus 6x squared. So the first one is a polynomial. The second one, x raised to the 3 halves minus 2x to the negative 1 is not a polynomial. And then it gives you some useful information. It says, there are no square roots of variables, no fractional powers, and no variables in the denominator of any fractions. If you see any of those, then the expression is not a polynomial. Simply put, polynomials have variables with whole number exponents. X to the first, x to the third, x to the 18th. As soon as you throw in negative numbers or decimals or fractions or square roots, then it's no longer a polynomial. Well, if we back up a little bit, we see the word term. Polynomials are distinguished in two ways, and one of them is by the number of terms. So if you had 2x squared, that is one term. You can line up as many multiplications as you want, and that is a single term. Like 4x squared, y to the 5th, z to the 19th. That is one term because it's all multiplication. As soon as you start adding, then you talk about different terms. So if you look down below, a polynomial with only one term is called a monomial. Mono being one. So 6x to the 4th is one term. A polynomial with two terms is called a binomial. A polynomial with three terms is called a trinomial. And 4 would be a quadrinomial. And after that, we kind of just get lazy and we just say it has 5 terms or 8 terms or 21 terms. Maybe the worksheet today will go up to 4, and we'll call it a quadrinomial. Usually, we put polynomials in standard form according to their exponents. So x to the 4th, x to the 3rd, x squared, x, and then the constant. What is the exponent on a constant? If I look at the end of this and I have that plus 3, what is the value of the exponent? Because this is kind of tricky. Most students don't see this the right way. Well, what's the exponent on the 3? If it's not listed. 1. It's to the first power. But we don't care what the exponents are on the constants. We want to know what the exponents are on the variables. So if we follow it down, 4, 3, 2, 1, this one should be, if we follow the pattern, what would the exponent be? Okay, let me try that again. 4, 3, 2, 1. That one should be a 0. Well, it is. 3x to the 0 is, in fact, the exponent. What is x to the 0? 1. Okay? Any number to the 0 is 1. So 5 to the 0 is 1. So x to the 0 is 1, and 3 times 1 is 3. So anytime you don't see a variable, the exponent is 0. And that's important because we need to know what's called the degree. So one way to classify polynomials is by how many terms they have. The other way to classify them is by their largest exponent. Okay? So if we have what is called a constant, some number a, an example would be 5. The degree of a polynomial is the value of the largest exponent. And that largest exponent will tell us what the graph is, what family the graph fits in, whether it's a straight line or a parabola or something bigger. Okay, so that would be degree 0. If we had a linear equation, negative 2x plus 1, we have two exponents. We have an exponent to the first. We also have an exponent to the 0. The degree is the bigger of the two. So all linear equations have degree 1, x to the first. Okay. The next one, if you look at it, what is the degree of a quadratic? What is the largest exponent on a quadratic equation? 2. Degree 2. So this one is a trinomial, meaning it has 3 terms of degree 2. Trinomial, 3 terms, largest exponent is a 2. So if you look at your naming polynomials worksheet, name each polynomial by degree and number of terms. How many terms does it have? It has 2 terms, so it's called a binomial, and the degree is, what's the value of the largest exponent? 4. So that is a binomial of degree 4. Binomial of degree 4. Well, if you just write 4, binomial 4, that doesn't make any sense. You have to write of degree. Not that kind of degree. Not that kind of degree. Well, do what you want. You just won't get credit. Yeah, do whatever you want, Robbie. And you haven't learned your lesson, have you? Okay, look at number 2. What type of polynomial is number 2? Monomial. It only has 1 term. What is the degree of degree 1? What about number 8? It's a monomial. Not no degree, degree 0. It has a degree, it's degree 0. Monomial. Mono means 1. So it would be monomial of degree 1. Okay. What did we decide a 4-termed polynomial is called? Quadrinomial. Good. Okay. For the second worksheet, you're going to be adding and subtracting polynomials. In order to add and subtract polynomials, you have to have what are called like terms. Like terms are 2 terms where the variable and exponent are the same. So we have here 2 binomials. There's a binomial, and we're going to add that to another binomial. Do I have any like terms between those 2 binomials? The p squareds. Those are the only like terms. And when we add polynomials, we always write them in standard form, which means we start with the biggest number, the biggest exponent, and we work our way down to the smallest exponent. So the biggest exponent in this case is the negative 3p to the third. Does it have any like terms? Are these like terms? No, they don't have the same variables. So we're going to write negative 3p to the third. Excuse me. Oh, sorry. Okay, So the next biggest one would be the p squareds. Do I have like terms with the p squareds? Yeah, I have a 5p squared and a 2p squared, and when I add those together, I get 7p squared. And the only thing left is that negative 3. So if there are like terms, you can put them together. If there are not like terms, then you can't. Okay, number 2. Actually, let's do number 3 first. So my biggest exponent is a 3. So I'm going to put the n to the thirds together. Number 3. So 2n to the third and 5n to the third is 7n to the third. And then I don't have any n squareds, and I don't have any n's, but I do have constants. 4 plus 2 is 6. Now, I don't have the answers to these worksheets printed out, but if you go to my web page and you click on the assignment, there will be 4 pages. The first 2 pages are the assignment, and the last 2 pages are the answers. So you can go home and get the answers to these. So that'll help you out. Number 2 is a little bit different because it's a subtraction. Whenever there's a subtraction, you have to bring that subtraction into the polynomial. So I'm going to take this subtraction and I'm going to bring it in and hit all of the terms with the subtraction. So what is that negative going to do to the 3a squared? It's going to make it negative. So it's minus 3a squared. What's the negative going to do to the negative 4a to the third? Change it to positive. So plus 4a to the third. Now, do I have any like terms? I have a to the thirds. I also have a squareds. So I can bring my a to the thirds together, which gives me a total of 5a to the third. Then I'm going to bring my squareds together. When I combine those, how many 8 squareds do I have? Negative 5a squared. Okay. So that assignment should be pretty easy. Hopefully it's review of stuff that you did in years past. The last thing we need to talk about is the assignment we did on page 18 in the book. So we learned everything except part B, starting with number 4. So in number 4, we have one term that's being multiplied to 2 terms. In 1, 2, and 3, it was really easy because it was 1 term times 1 term in all of them. But you'll notice in number 4, we're doing 1 term times 2 terms. And that changes things a little bit. We need to do what is called distribution. We need to distribute that 1 term across the other 2. So, move this up. The way I'm going to work this is I'm going to take my root 6 and I'm going to multiply it by both of the other terms. Now remember, I'm allowed to multiply because they have the same square root. They're both square roots. If one was a square root and one was a third root, we wouldn't be able to multiply them in most cases. So, a square root of 6 times the square root of 3 is just the square root of 18. If the roots are the same, you multiply the numbers on the inside. Does that make sense to everybody? Okay. For the second one, the square root of 6 times the square root of 12 plus the square root of 72. Now I need to simplify them to see if I can add them together. So I'm going to factor the 18, 3 and 6, 2 and 3. What am I looking for? How do I know it's pairs and not triples or quadruples? It's a square root. Square roots mean look for pairs. Third roots mean look for triples. So I have a pair of 3's. So I write 3 on the outside. Did I have anything left? I had a 2 left over. Plus, if I factor 72, I get 8 and 9. And 8 is 2, 2, and 2. And I just kind of have that memorized. If you see an 8, 8 is made up of 2 times 2 times 2. So in the 72, do I have any pairs? I have a pair of 2's and a pair of 3's. So what can I bring out? The 2 and a 3, which gives me 6. What's left on the inside? A 2. Now that I have them simplified, can I add them together? What allows me to add them together now? They are like terms. They're both square roots of 2. So if it just says add, that doesn't mean you can put them together. The only time you can add them together is if this matches that. It's just like saying, if I had 3x plus 6y, can I add those together? No, but I can add 3x plus 6x together. So if I do 3 roots of 2 plus 6 roots of 2, I get 9 roots of 2. Yes? 5,000 square miles. 25,000 miles. Yep. Okay. Number 7 is a little bit different. Robbie, you might want to pay attention to this. So in number 7, it's different from 4. In number 4, I had 1 term times 2 terms. But in number 7, I have 2 terms times 2 terms. So I need to distribute both of them. So I'm going to take the root 5, and I'm going to multiply it across. When I'm done, I'm going to take the root 3 and multiply it across. And then I'll see if I can simplify in the end. Okay? Hopefully you've done something like this before. Yeah, it is. So root 5 times root 5 is root 25. And then root 5 times root 3 is plus root 15. Now I move into the denominator, or sorry, the second half. Negative root 3 times root 5 is minus root 15. And negative root 3 times positive root 3, what is that going to give me? Will that be positive or negative? Negative, because a positive and a negative is a negative. Minus 3 times 3 is 9. Can I simplify that at all? How? So the square root of 25 is 5. And the square root of 9 is 3. What about the other two terms? What is root 15 minus root 15? 0. They cancel. Is that always going to happen? No. So in this case, we end up with 5 minus 3 is 2. Why did those middle two terms cancel? And why did I get a positive root 15 and a negative root 15? What about the original problem made that middle term cancel out? So if I focus in on here, what is it about that organization that left me with a root 15 and a negative root 15? This is kind of a hard question. So it's 5 and 5, 3 and 3. And they're exactly the same except for the negative. Do you notice the first parenthesis has the same numbers as the second parenthesis, but the sign between the two numbers are different. The first one's positive and the second one's negative. Whenever that happens, these middle two terms are going to cancel. But let's work number 8. It doesn't happen in number 8. So, I'm going to multiply these together. So I take negative 2 and I times it by 1. So I get negative 2 square root 3 times 3 is 9. Now I move on to the next one. How do you do negative 2 root 3 times negative 5? Am I losing you? How do I multiply that first term in the first set of parentheses to the last term in the second set? How do I multiply negative 2 root 3 with negative 5? Well, I multiply the numbers in front by the numbers in front and the numbers inside by the numbers inside. Well, this one doesn't have anything on the inside, which means it's a 1, root 1. So I do negative 2 times negative 5 is negative 10. Square root of take a look at it. What goes inside here? If I have negative 2 root 3 times negative 5, I'm going to get negative 2 times negative 5 is negative 10. Square root of, positive 10. Square root of, well, what do I have to work with? I have a 3, and I also have the one that doesn't show up here is a 1, and we can just ignore it, so it's just 3. So that would be a 3. Okay. Now we move on to the next set. We do positive 2 times root 3, which is just 2 root 3. And then the last set is minus 10. So, can I simplify root 9? What is root 9? 3, and when I times that by the negative 2, I get negative 6. Can I simplify my 2 root 3's? What do I get with 10 root 3 plus 2 root 3? Plus 12 root 3, and then minus 10. They're not negative, are they? No? So I have a negative 6 and a negative 10. So minus 16 plus 12 root 3. So let's look at number 10. 10's a little bit different. And 10's actually quite hard. When you're multiplying roots, the only time you can put them together is if the roots are the same. And on number 10, I have a third root, and I have a fifth root. But the bases are the same. And this is a little bit beyond the scope of this class, but this is like saying 6 to the 1/3. A third root is the same as the 1/3 power. And a fifth root would be the 1/5 power. So 6 to the 1/3 times 6 to the 1/5. And because they're both 6's, we can add the exponents. So I'm allowed to add these together. Now, you can do that on your calculator, so if you have a calculator, pull it out. If you don't have a calculator, you need one desperately. Without it, you will fail the next chapter. I mean, you literally cannot do it without a calculator. a graphing calculator. So this calculator does not have a fraction button. You just use the divide button. So I would type in 1 divide 3, oops, 1 divide 3 plus 1 divide 5. And then I want to tell the calculator to give me a fraction answer. If I just hit enter, I get a decimal. And to turn that into a fraction, you push math, and the first one says arrow, triangle, fraction. That means turn your answer into a fraction. So if I hit enter on that, I get 8/15. And you can actually do all of that in one step. So 1/3 plus 1/5, and I can put the fraction button right there, and that will convert it into a fraction. So number 10 is actually 6 to the 8/15. So number 11 is going to be 1/4 plus, is that a seventh? I can't see. Yeah. 1/4 plus 1/7. Those are the exponents. So 2y raised to the 1/4 plus 1/7 math fraction gives me 11/28. And number 12, we have z to the 1/8. And then outside of that, we have a 1/3. Whenever you have exponent to an exponent, you multiply them. So we're going to take 1/8, we're going to times it by 1/3, and then change that into a fraction. So it's z to the 1/24. So you need to turn in that Forrester 1 worksheet that we worked on Friday. These two worksheets I gave you today, and the rest of pages 18 and 19 are due tomorrow. But let's talk about page 19. 19 looks really tough, but it's easy. It says, can you write the result of 2 plus 4/5 as the ratio of two numbers? This is just asking, can you create a rational number, a fraction, using just these two numbers? Well, if you don't know, plug it into your calculator and see if it turns into a fraction. So 2 plus 4/5, math fraction. Yeah, the answer is 14/5. For number 3, if I add 2 plus 1/2, is that it, or is it 1/5? Oh, 1.5, sorry. 2 plus 1.5, math fraction. Yes, I can write it as the ratio of two numbers. It's 7/2. But if I were to do something like 4 plus the square root of 7, math fraction. Oh, you got to get your fraction outside. 4 plus square root of 7. If I try to turn this into a fraction, it doesn't work. So the answer would be no. It cannot be written as the ratio of two fractions. So finish that up. It's due tomorrow.